Hello class, this is a video tutorial on calculus using different bases. Since we've only applied differentiation to e to the power of x, we have to apply the inverse identity of exponents and logs of the same base in order to differentiate exponents of different base. This long mouthful here is actually referring to this one. If we have some exponent a and log base a, so if we raise, if we have the power of a base as the log of the same base, these two are inverse and they cancel one another, leaving us only with x. Here's an application of this. So let's say we had 2 to the power of x. We could just raise this to the power of 2 and take the natural log of this. By doing this, it's as if we're multiplying by 1. So nothing really changes, because this expression, if we cancel these two, brings us back here. Now the reason why we would do this is we can now take that x as a coefficient of ln. Now ln has become a constant, that's just ln of 2, it's a number, and this here is e to the x, in which we can differentiate. In this form we can differentiate or integrate by the regular methods of d dx, e to the power of u. So I'm going to demonstrate to you using these 3 examples. Here we go. So first we need to change this expression to become, I'm going to do this in steps so you can follow along. F of x equals, I'm going to take the natural log of this, natural log of 2 to the x, and then move this by log laws, that becomes the coefficient. So this becomes x ln of 2, but in order to not change the appearance, or so not change the value of this, because we took the natural log, we now have to raise this to the power of e. So this is actually becoming e to the x ln 2. We can now derive this. This is now going to be f prime of x. The derivative of e to the x is always itself, so e to the x ln of 2. But we now need the derivative of x ln 2. Well, because ln 2 is a number, okay, so think of this as 2x, but I know it looks kind of funky. It's x2 because it's x ln 2, so that is just a number. When we differentiate just x, we take just that number, so ln 2 times e to the x ln 2. So this here is the derivative of 2 to the power of x. We'll do this one more time. Let's change this first. I'm going to skip a few steps now. This just becomes e to the x ln 10. Differentiating this, g prime x becomes ln 10 e to the x ln of 10. For this one here, we'll change this first to 3 to the power of negative x, and in which case we can apply the same concepts here. This time I'll do it in steps again. We take the natural log and raise this to the base e. So this becomes e ln 3 to the power of negative x. Because remember, these two will cancel, bringing us back to the original. So it's the same expression, which looks different. We can move that x as a coefficient by log laws. So this becomes e to the negative x ln of 3. Differentiating this, h prime becomes, well, it's always the same expression, so e to the negative x ln of 3. The derivative of negative x ln 3 is negative ln 3 times e to the negative x ln of 3. So now let's find the gradient of these at 4. This is very straightforward because we've done this so many times. To find the gradient of the tangent at that point, we just substitute f prime of 4. Well, that's just going to be ln of 2 e to the power of 4 ln 2. Reversing this process, we can find this in exact form. This is ln of 2 e to the ln of 2 to the power of 4. These cancel. 2 to the power of 4 is 2, 4, 8. That's 16. So ln of 2 times 16, or we can just leave this as 16 ln 2. And there we have it. Let's do it like here again. We want it at g prime of 4 because we want the gradient of the tangent at x equals 4. Once again, that's ln 10 times e to the power of 4 ln to the power of 10. Moving that, reversing the process, that's like so. E and ln cancel. 10 to the power of 4 is 10 with 4 zeros, so 1, 2, 3, 4. 10,000 ln 10. We can leave this in exact form. You can approximate it if you'd like. One last time here. H prime of 4. It's negative ln 3 times e to the power of negative 4 ln of 3. Reversing this coefficient becomes the power. So negative 4. E and ln cancel. Negative natural log times, well, 3 to the power of 4. I'm just going to grab a calculator for that. 3 to the power of negative 4 is 1 on 81. And then simplifying this fraction becomes negative ln 3 over 81. Well, I hope that gave you an insight into expressing bases in terms of e in order to differentiate them. So I hope to see you in the next video. Best of luck.